we, in sort of brainstorming what we were going to do, I was thinking a lot about what I like to do recreationally, which is hike. And in 2020 and 2021, there was a huge uptake in outdoor usage of outdoor recreational spaces because of the pandemic, which was great. But this was not without an impact on the environment itself. And so we sort of set out to see if we could quantify some of that impact. So Claude, if you go to the next slide here. And so we have this great resource on campus, the UCR Botanical Garden, and in consultation with the staff there, they agreed to let us conduct our study there. And so we decided to look into the specific conservation practice of staying on a marked trail, and whether or not we could quantify the effect of violating this conservation practice. And in the UCR Botanical Garden has this great trail network, and it also has a pretty diverse landscape that this trail network covers, and it has a huge, very high visitation rate. So it's sort of the perfect site for us. And so we went out to the garden and we looked for instances like what you see in this photo here. This is a unofficial trail that is slowly developing from people deviating off of the official trail. And so we looked for these instances to set up our study. So if you go to the next slide, perfect. So our study objective that we chose to focus on was soil infiltration rates. We wanted to evaluate the effect of on and off trail hiking on soil infiltration rates. And we used these instruments called Saturos. They're dual head infiltrometers, and they allow for automated data collection over a long period of time. And Dr. Hagberdi had a number of these, which was sort of perfect for us setting up these side-by-side comparative locations where we had one on the trail and we had one on a unofficial developing trail, and then in an undisturbed location where we could put these up in situ and look at them all at the same time. And to date, these mostly had been used in literature for agriculture studies, urban green infrastructure, such as rain gardens, and some post-burn studies, but not for this specific usage. We go to the next slide. And so in selecting our sites, it's important to think about like the main controls on soil infiltration. So there's the soil properties themselves. There's also the vegetation, land use, rainfall and or irrigation practices. And so our main sort of conceptual map here is that when you have rainfall that exceeds the infiltration capacity of the soil, so water is falling on a soil surface faster than that water can infiltrate into the soil surface, that's when you get runoff. And when you have runoff, you can mobilize soil particles, which is then erosion, moves that in a downslope direction, and that can lead to land degradation. And so that was sort of what we set out to look into.
All right. So to collect data, we collaborated with the managers at the Botanic Garden, and we first identified like the longest trail that people normally take. And then from that, we identified 6 different locations, as you can see on this side. And you can see we try to cover everything where we have more vegetation, no vegetation cover, or steep slope, or kind of flat, so that we can make sure we represent what's happening in the garden. And we collected 3 different data. So the first one was saturated hydraulic conductivity, as Claire mentioned, using Saturos. And we also measured soil moisture using a handheld sensor, but also we did measure gravimetric water content by analyzing soil samples in the lab. We also measured the bulk density and the soil water content. As you can see on this photo, it kind of highlights what the sampling locations. So we first identify what is official trail, as you can see on this side, and it's very clear where you should people should go. And this is undisturbed. Again, it's covered by grass, so it's not disturbed, but all like this one where it kind of shows where people take a shortcut. And so we kind of did this at the same time so that we kind of make sure that we don't measure after like few days or there's a difference in time which can affect the results. Like Claire mentioned a little bit about the instrument. So this instrument has like water and then it kind of soak the soil and then measure how much is being infiltrated in the soil. And this is again the photo that shows the more specifics about the instrument that we used. And again, we collected soil core samples to kind of also do some measurements in the lab. Wanted to know the soil properties and gravimetric water content and the bulk density in the soil. So these three graphs kind of highlights the general data that we were able to find. So on the x-axis, we find disturbed, track, and undisturbed. So what disturbed mean is like undisturbed soil all cover. And we have track is where normally people should go through, like official track. And then there is undisturbed, which is normally undisturbed soil on the side. So disturbed is where people have violated the track where they're kind of cutting the shortcuts. On the y-axis, the first one is saturated hydraulic conductivity, the second is soil moisture, and the bulk density. Looking at the conductivity, you can see that for undisturbed, we have relatively higher conductivity, which means the soil, the soil water can go through easily as compared to the track and undisturbed. So you can see that by disturbing the soil, we assume that in the initial conditions, the disturbed condition was the same as undisturbed. But because of people violating or us violating from the official track, the conductivity was reduced to the extent where it's pretty much closer to what could be in the track. When you look at the moisture, so when we reduce the conductivity or when we violate the official track, we also increase the compaction. So when you increase the compaction, you reduce the amount of pore spaces where water could be served in the soil. So you can see that the undisturbed condition has more water content compared to disturbed and track. This is because these two soils are compacted, so they can hold more water. They can hold much water as undisturbed conditions. When you look at the bulk density, also you can see that the disturbed and track, they kind of have pretty much the same bulk density, but when you look at the undisturbed condition, you see that it has slightly lower bulk density. And this was average for the whole sampling for all sampling locations. Again, this is our results from the instrument that shows us how much water was being infiltrated, and you can see that overall in many sites, the green one shows in undisturbed, and you can see that we had more water infiltrating in the soil at those places which were not disturbed, but slightly like very low water infiltrated in those sites that were disturbed at over a period of 150 minutes. Again, this shows kind of the spatial distribution of where we collected the samples, and you can see that we also did see some other impacts. You can see that on the steep slope, we see relatively higher conductivity, which I believe might be also the impact of gravity. And you see that also we, like different sites kind of had different conductivity. Mainly it could be caused by vegetation cover on the slope or the soil type. But the general trend, when you average everything, you see that again, the undisturbed has higher conductivity compared to disturbed in the track. As a take-home message, we have seen that deviating from official trails leads to soil compaction. And in this study, we have seen that assuming that the disturbed and undisturbed started at the same conditions, we have seen that by deviating from the official trail, the disturbed condition reduced the conductivity by 61%. And when we talk about this in irrigation perspective, if this is, let's say, for an irrigated land, this could lead to runoff and water loss. So I guess this is more helpful when we're trying to analyze irrigation efficiency, to also put into consideration the behaviors of people, so that if we are compacting the soil, we have to know that we have to put that into consideration on when we are estimating how much to irrigate or how long we have to irrigate, because the uh, the hydraulic conductivity is going to be reduced.